Venus is a planet seemingly similar to Earth, one that has fascinated humanity for centuries with its brilliance and mystery. It's also the second brightest object in the night sky, right after the Moon. Yet beneath its dense cloud cover lie extreme conditions that have challenged astronomers and engineers for decades. Let's take a closer look at the second planet in our solar system. Ancient civilizations observed this bright point in the sky with fascination, noticing it appearing just before sunrise or shortly after sunset. However, it was only around the 6th century before the Common Era that the Pythagoreans realized these 2 points were the same celestial body. Venus was named in various cultures after goddesses associated with love and beauty, such as Ishtar in Babylon, Aphrodite in Greece, and Venus in Rome. This admiration for the beauty of the planet connected ancient civilizations, seeing it as more than just a bright spot in the sky. But why exactly is Venus so bright compared to other planets? The reason is its relative proximity to Earth and the planet's dense clouds, which effectively reflect sunlight. For thousands of years, Venus was observed only with the naked eye. A breakthrough came in the 17th century when Italian astronomer Galileo Galilei directed his telescope toward it. These observations significantly impacted astronomy, as Galileo discovered that Venus has phases similar to the Moon, providing irrefutable proof that the planet orbits the Sun. Further observations were made by astronomer Giovanni Cassini, who attempted to determine Venus's rotation period. However, due to the thick cloud coverage, he couldn't observe its surface. Only in the 20th century, with the advancement of radar technology, was it discovered that Venus rotates extremely slowly and, surprisingly, in the opposite direction to most planets in our solar system. Intriguingly, Venus completes an orbit around the Sun in 224 Earth days, while a full rotation on its axis takes about 243 Earth days, meaning one day on Venus is longer than its year. This is unique in our solar system. Significant contributions to Venus exploration were made by the Soviet Venera program, a series of missions intended to gather data from the planet's surface. The first probe, Venera 1, was launched in 1961, but contact was lost. Subsequent missions provided increasing amounts of information about conditions beneath the dense clouds. Venera 4, for example, was the first to measure the chemical composition of Venus's atmosphere, confirming that it primarily consists of carbon dioxide. In 1970, Venera 7 became the first spacecraft to successfully land on another planet, transmitting data from the surface, including temperatures around 470 degrees Celsius, about 878 degrees Fahrenheit. The probe lasted only 23 minutes under extreme conditions before losing signal. Besides the intense heat, the culprit was pressure over 90 times greater than on Earth, equivalent to conditions more than a kilometer beneath our oceans. To understand the scale of this technological challenge, consider that modern military submarines struggle to withstand such pressure and typically don't dive deeper than 600 meters. But let's return to the topic of Venus. What astronomy enthusiasts had long awaited were images from the planet's surface finally delivered in 1975 by landers Venera 9 and 10. They revealed a rocky basaltic landscape indicating a volcanic past. Despite Venus being closer to the Sun than Earth, the thick cloud layers scatter and block sunlight so effectively that its surface remains dimly lit. While the Americans primarily focused on manned lunar missions during that period, they also sent several probes toward Venus. Though none landed on the surface, missions like Mariner 2 and later Magellan, which entered Venus orbit in the 1990s, utilized advanced radar systems to create highly detailed surface maps. These missions also provided crucial information about Venus's scorching climate and the intense winds within its dense atmosphere. Thanks to these missions, humanity began viewing Venus not as a mysterious, cloudy globe, but as a planet with drastically different conditions from Earth. It became clear that Earth's twin, as Venus was once called, turned out to be the most inhospitable planet in our solar system. Data collected by Soviet and American probes formed the basis for upcoming missions. Among the most anticipated future missions is Da Vinci, aimed at analyzing the atmospheric composition and capturing high-quality images of the surface. Another NASA mission, Veritas, will create precise geological maps of Venus, improving our understanding of its tectonic and volcanic history. The European Space Agency also plans its own mission, Envision, to further investigate the planet's structure and atmosphere. These future explorations may answer questions regarding the possibility of ancient oceans on Venus and trace the climate changes that led to its current extreme environment. Technological progress and growing interest in Venus research bring us closer to uncovering the mysteries of this fascinating planet. Perhaps this research will also enhance our understanding of changes occurring here on Earth. Though currently unable to send crewed missions to Venus, the future of exploring our closest planetary neighbor looks incredibly exciting. And since Venus is on an inner orbit of our solar system, can we observe its transit across the Sun? Absolutely. It's worth marking your calendars. The next transit will occur in the year 2117. Meanwhile, I'm preparing to explore the next planet in our solar system. As Polish astronaut Mirosław Hermaszewski, who flew into space in the 1970s, once said, "From above, it's absolutely stunning. I looked at it as if enchanted. A wonderful blue planet surrounded by a thin layer of atmosphere, looking like a mist. That's when I realized just how fragile it is." We all know the planet he saw, the third planet of our solar system, our very own Earth.